In this video, we're going to look at basic angle relationships. And before we get to that, let's start out with some basic information about angles. An angle is the union of two rays with a common vertex. Okay, so what we're going to do, we're going to take two rays, we're going to join them together, which is why it's called a union, and the two rays are going to meet at the same vertex point. And this is an example of what that would look like, okay? The two rays that make up this angle, all right, if I name the rays here, the rays are the ray AT, starts at A and goes through T, and the ray AM, all right, starts at A and goes through M. These two rays were joined at point A, so that's the union point of the two rays. And to name an angle, all right, one way that you can name it is by three letters. Okay, and if you name it by three letters, you're going to go out as far as you can on one of the rays into the vertex point and then out as far as you can on the other ray. So for example, angle TAM. So we write the angle symbol TAM. All right, that is angle TAM. Or we could have started out on this ray and then gone to point A, the vertex, and then out on the other ray, so angle MAT. Either one of those is an acceptable name for this angle. All right, the other way that you can name this angle is by the vertex point if it's the only angle at that vertex point. All right, and this example, this is the only angle with the vertex point of A, so I could just call it angle A if I wanted to, okay? But if there was more than one angle at the vertex point, then you couldn't call it that because then I wouldn't know which angle you were talking about. Now, in elementary school, we learned about a few different types of angles. There is an acute angle, a right angle, an obtuse angle, and a straight angle. We're going to review each of those here. An acute angle is an angle that measures between 0 degrees and 90 degrees. All right, and if we were to draw a picture of it, it could look something like this. Okay, that's something between 0 and 90 degrees. It might look something like that. That's between 0 and 90 degrees. It could be a very small angle like that. That's between 0 and 90 degrees. Those are all good examples of acute angles. A right angle is an angle containing exactly 90 degrees. And the way that we draw a right angle, we draw two lines that are perpendicular to each other. Perpendicular meaning that they form a right angle. So it could look like that, or we could draw the picture maybe something like this. Okay, each of those represent right angles. An obtuse angle is an angle measuring between 90 degrees and 180 degrees. Okay, so it needs to be bigger than a right angle, but smaller than 180 degrees. So maybe it looks something like this. Okay, this is an example of what an acute angle, or excuse me, an obtuse angle would look like. Or I could draw the picture maybe something like that. Okay, each of those represents an obtuse angle. And finally, a straight angle is an angle containing exactly 180 degrees. And we call it a straight angle because it would look just like a nice straight line. Okay, so those are the four different types of angles that you learned about in elementary school. Now, in this next diagram, what we're going to do is name each of the numbered angles in the picture. You can see in this picture, I've got angle number 1, angle 2, angle 3, and here is angle number 4. All right, notice that all of those angles meet at the same vertex point right here, point A. So I can't just say that the angles are point A because, well, there's many different angles that meet at point A, so I wouldn't be able to know which one that it is. So here's angle number 1 between these two rays here. And again, to name a ray, I'm going to name it by the three letters since I can't name it by just the vertex point. So I'm going to start out as far as I can on one of the rays. I'm going to move into the vertex point and then go out as far as I can on the other ray. So this I could name angle BAD or angle DAB. Either one of those is an acceptable name for that angle BAD or angle DAB. Angle number 2 right here is in between these two rays. So again, I'm going to start out as far as I can on one of them, angle D, A, and then out on the other one is F, angle D, A, F. Or if I started out on this one, angle F, A, D. Those are the two different names that I could give angle number 2. Angle number 3 is between these two rays here, so I can name it angle EAF, angle EAF. Or I could start out here at point F, angle FAE, angle FAE. And finally, angle number 4, which is right here between these two rays, and this is a 90-degree angle. Okay, it's got that 90-degree symbol box right there. I could start out here on this ray, angle CAB, or I could start out on this ray, angle BAC, angle BAC. Either one of those would be an acceptable angle name for that angle. In this next part of the video, we're going to look at different angle relationships, beginning with adjacent angles. Adjacent angles are angles with a shared ray, a shared vertex, but no shared interior points. Okay, adjacent angles share a ray, they share a vertex, but they do not share interior points. Okay, and so I'm going to look at two different diagrams. One shows a good picture of adjacent angles, one shows a bad picture because the angles actually aren't adjacent to each other. We'll start with the good picture. First is angle ABC, all right, angle ABC right here. There's angle ABC. And then the other one is angle CBD. Angle CBD is this angle here. Okay, so do those angles share a ray? Well, they do. They share this ray right here. That ray right there in the middle is ray BC. Ray BC is the ray that both of those angles share. The vertex point of each angle is the same. ABC, CBD, they share point B as the vertex. All right, but the interior points are not shared. The interiors do not overlap. Angle ABC is the space in between these two rays, and angle CBD, the interior, is the space in between these two rays. There are no shared interior points. All right, the angles are completely separate. Compare that now with this picture over here. We have angle ABD, which is this big angle right here, angle ABD, and then compare that to angle ABC, which is this angle right in here. Okay, do these angles share a ray? Well, ABD and ABC, well, yeah, they both share this ray right here, which is ray BA. Ray BA is the shared ray in this example. Do they share a vertex point? Well, they do. Angle ABC, there's the vertex. Angle ABD, there's the vertex. It's point B again. Okay, so they do share a ray, they do share a vertex, but it says that they can't share interior points. But if we look at this closely, angle ABD is this big angle, so the interior is everything in between those two rays, which includes angle ABC. So these two angles' interiors actually overlap. Angle ABD, which is the big angle, contains angle ABC. Okay, and for that reason, these are not considered adjacent angles. The best way to think about adjacent angles are neighbors. They're next door to each other. Okay, so for example, in this picture, ray BC was the shared ray, but it's kind of like a fence that divides the property between angle ABC and angle CBD. That's the fence right there. Okay, but in this picture over here, we have angle ABC, but angle ABD overlaps that angle, okay, so it has shared interior points. So again, adjacent angles, best way to think about them, they're neighbors. They're right next door to each other. The next angle relationship that we're going to study are what are called complementary angles. Complementary angles are two angles whose sum is 90 degrees. Okay, two angles whose sum is 90 degrees, meaning that if I add them together, because they make 90, that means if I put them together, they would create a right angle. And that's what we see right here in this picture. We have angle A, which is this angle right here, and we have angle B, which is this angle right here. Now, complementary angles in this example, they do not have to be adjacent to each other, but when we do put them together and make them adjacent like this, they form this right angle. So I can say that the measure of angle A plus the measure of angle B equals 90 degrees when we add them together. Another way to look at it, in this picture right here, I've got this 60-degree angle and I've got this 30-degree angle, and when I put them together, they have created the right angle. 60 degrees plus 30 degrees is equal to 90 degrees. All right, so that's what complementary angles are. What about supplementary angles? All right, well, supplementary angles are two angles whose sum is 180 degrees. Two angles whose sum is 180 degrees. And again, supplementary angles do not have to be adjacent to each other, but supplementary angles that are adjacent are called a linear pair. And we call them a linear pair because they form a straight line. And you can see that here in this picture. Here's angle C, it's this obtuse angle. And here's angle D, this acute angle. Now, if I put them together, they have created this nice straight angle that we see down here. So we can say that the measure of angle C plus the measure of angle D is equal to 180 degrees. They're supplementary and they're a linear pair because they've created a straight line, a straight angle. If I look at these measures right here, here's a 120-degree obtuse angle, here's a 60-degree acute angle. When I put them together, I create this straight angle here, making them a linear pair of 180 degrees. 120 degrees plus 60 degrees is equal to 180 degrees. In the next few examples, we have some missing angles whose measures I've represented with a variable. Here's a z, here's an a, y, an x. What I want to do is calculate the measure of each missing angle in each picture. And in order to be able to do that, I have to think about what the angle relationship is between the unknown angle and the labeled angle. In this example, I have this acute angle, which is 55 degrees, and I have this obtuse angle here, which I've labeled as z. I want to know how many degrees is the measure of angle z. And in order to figure that out, I realized that when I put these two angles together, they formed a straight angle here, meaning that they are supplementary. And supplementary angles will always add up to 180 degrees. So I can say that the measure of angle z, my unknown angle here, plus 55 degrees is equal to 180 degrees because all straight line angles, straight linear angles are 180 degrees. To get the measure of angle z, then all I'm going to have to do is subtract 55 degrees from each side. And when I do that, that's going to tell me that the measure of angle z is going to be 125 degrees. This angle, this obtuse angle, must be 125 degrees. Looking at this picture where I have angle A unknown, I again have to figure out what its measure is. And I know that this is an acute angle here. And I also have this obtuse angle of 137 degrees. And again, if I put angle A and 137 degrees together, notice that they've formed a nice straight angle right here. They're a linear pair. They are supplementary to each other. So in order to get the measure of angle A, I could add 137 degrees to it, and it will add up to 180 degrees again because all straight angles are 180 degrees. So to get the measure of angle A, all I'm going to do is subtract 137 degrees from each side. And when I do that, then that's going to tell me that the measure of angle A is going to have to be 43 degrees when I do the subtraction. Okay. Looking at my next picture, I have two unknown angles. I've got angle Y here, I've got angle X here. Notice that these angles aren't located at the same vertex point. Angle Y is at this vertex point here, while angle X is at this vertex point here. When you're looking for a missing angle, all you have to do is focus at the angles that are at the same vertex. Like back in this picture, A and 137 degrees were at that same vertex point, and in this picture, 55 and angle Z were at this vertex point. Because these are at different vertex points, I'm not going to use all of the angles at the same time. Let's start here with angle y. So I'm only going to look at this vertex point here. So I'm going to ignore everything that's over here. So imagine that that's not there. Okay, well, when you do that, notice that you've got this unknown angle, an acute angle, which I've called y, and I've got this obtuse angle right here, which I know is 157 degrees. And when I put them together, they have created a straight angle. They're a linear pair, meaning that these two angles are supplementary to each other. So to get the measure of angle y, I can take its measure and add it to the 157 degree angle, and they will add up to 180 degrees. So to get the measure of angle y, I'm just going to have to subtract 157 from each side. And when I do that, then I know that the measure of angle y is going to have to be 23 degrees. This angle here is a 23-degree angle. Now to get the measure of angle x, I'm only looking at this vertex point, so I'm going to ignore everything that's over at this vertex point. Pretend that's not there. All right, again, when I do that, here's angle x, some unknown acute angle. And here's another acute angle, which is 78 degrees. And notice when I put them together, they have created a right angle here, meaning that these two angles are complementary to each other. So to get the measure of angle x, I can take its measure and add 78 degrees to it. And when I add those together, they form a right angle of 90 degrees. So to get the measure of angle x, I'm just going to have to subtract 78 from each side. And when I do that, that means that the measure of angle x is going to have to be 12 degrees. This is a 12-degree acute angle in that picture. The next angle relationship that we're going to study are what are called vertical angles. Vertical angles are non-adjacent angles formed by intersecting lines. Non-adjacent angles formed by intersecting lines. Okay, so if I look at this picture down here, I've got these two lines that have intersected, and they have intersected at this point right here. All right, vertical angles are non-adjacent to each other, meaning they're not next door neighbors. So like angle M and angle 125, they are next door neighbors. They're not vertical to each other. Angle M and angle P, they're next door neighbors. They're not vertical angles. All right, but angle M and angle N, they're across from each other from this point of intersection. They're not adjacent to each other. So angle M and angle N are vertical. Same with this 125-degree angle and angle P. And one nice fact that's true about vertical angles are always congruent to each other. Vertical angles are always congruent, and the congruent symbol looks like that. All right, it's like an equal sign with a tilde on top of it. All right, so that's the symbol for vertical. So in this picture, I know that the measure of angle M is congruent to the measure of angle N, and I know that angle P and 125 degrees are congruent to each other, so angle P must be a 125-degree angle. If I wanted to get the measure of angle M or angle N, well, I do know that angles M and P are supplementary. They form this straight angle right here. So that means that the measure of angle P plus the measure of angle M has to be 180 degrees. Well, I know that angle P is 125 degrees plus whatever the measure of angle M is 180. So if I just subtract 125 from each side, then I know that the measure of angle M is going to have to be 55 degrees. So this is a 55-degree angle. And because angles M and N are congruent to each other, angle N must also be 55 degrees. Okay, so again, vertical angles, they're non-adjacent to each other. They're going to be across from each other from the point of intersection formed by these intersecting lines. And vertical angles are always congruent to each other. So we have some more pictures with some missing angles in there. And again, to find their angle measures, I'm going to have to use the angle relationships that I see in the picture. In this picture, I have angle X that's missing here. I have angle Y that's missing here. And again, they're at different vertices, so I'm only going to look at the specific vertex where those angles are located. So let's start here with angle X. Angle X is right here, and it's at this vertex point, right along with this 57-degree angle here. So I'm going to ignore everything else that's happening over here. Now, if I take angle X and I take this 57-degree angle and put them together, notice that they have created a right angle here, meaning that these two angles are complementary to each other. So their sums add up to 90. So that means if I do the measure of angle X plus 57 degrees, it's going to have to add up to 90 degrees. So to figure out how much angle X is, I'm just going to subtract 57 degrees from each side. And when I do that, that means that the measure of angle X is going to have to be 33 degrees. This is a 33-degree angle. Now to get the measure of angle Y is at this vertex point with the 131-degree angle. So I'm only going to look at that part of the picture. Angle Y is this acute angle here, and 131 degrees is that obtuse angle. And when we put them together, they have formed a straight angle. They're a linear pair. They are supplementary to each other. So if I take the measure of angle Y and add it to the 131-degree angle, because they are supplementary, their sum is 180 degrees. So to get the measure of angle Y, let's just subtract 131 degrees from each side. And when we do that, that means that the measure of angle Y is going to have to be 49 degrees. All right, this angle right here is a 49-degree angle. In my next picture, I have three missing angles. I've got angle X up here, I've got angle Y down here, and I've got angle Z right here. Now, in this picture, there's one angle whose measure I can get right away without doing any work, and that's angle Y. And the reason I can get angle Y right away without doing any work is because I see that I've got intersecting lines here and here. There's the point of intersection. Angle Y and 42 degrees are vertical angles. They're non-adjacent. They're across from each other from this point of intersection, and vertical angles are always congruent to each other, which means that angle Y has to be a 42-degree angle. Now let's see if we can get the measure of angle Z. Angle Z is this obtuse angle here, and if I use the 42-degree angle here, well, they are supplementary because they form this straight angle found right here in the picture. Meaning that if I take the measure of angle Z and I add it to 42 degrees, I have to get 180 degrees. So to figure out the measure of this angle, let's just subtract 42 from each side. Minus 42. And when we do that, the measure of angle Z is going to have to be 138 degrees. This is a 138-degree angle. Now to get angle X up here, I'm only looking at this vertex point, and this 132-degree angle is at the same vertex point. When I take the 132-degree angle and angle X and put them together, they form this straight angle here, meaning that these two angles, again, are supplementary to each other. So to get the measure of angle X, I'm going to add it to the 132-degree angle, and it must give me 180 degrees because they're supplementary. Subtract 132 on each side, and when we do that, that means the measure of angle X must be 48 degrees. This is a 48-degree angle in this picture. In our next couple of pictures, not only do we have missing angles in each example, but we're also going to have to figure out their angle measures and give a reason how we know that that is the angle measure. So we've got missing angle number 1, angle 2, and angle 3. Now you don't have to go in order here, all right? The first angle doesn't rely on the second and the third and so on and so forth. But I'm going to look for an easy angle whose measure I can get right away. And looking in my first diagram here, I see that this line intersects with this line right here. And intersecting lines form vertical angles. Vertical angles are non-adjacent and they're across from the point of intersection. So angle 3 right here is across from this 143-degree angle. Vertical angles are always congruent to each other. So this angle here must be 143 degrees. So I can write that in down here. The measure of angle 3 is 143 degrees, and the reason I know that is because it is vertical to 143 degrees. It's vertical to this 143 degree angle, and since vertical angles are congruent, then angle 3 measures 143 degrees. Now let's see if we can get this angle number 2 in the picture. Angle 2 is right here, and if I put it together with the 143 degree angle here, notice that they form this straight angle here, meaning that they're supplementary. So to get the measure of angle 2, I'm going to have to do 180 minus 143. And when I do that, I get 37 degrees. So the measure of angle 2 has to be 37 degrees because it is supplementary. It is supplementary to 143 degrees. Together, they form this straight angle. Now to get angle number 1, which is at this vertex point here, along with the 35 degree angle, when I put 35 degrees together with angle 1, they form a right angle, making them complementary to each other. So to get the measure of angle 1, I'm going to have to do 90 minus 35, which is going to equal 55 degrees. So the measure of angle 1 is 55 degrees because it is complementary. It is complementary to 35 degrees. Okay, together these two angles created a right angle of 90 degrees. Their sum adds up to 90. In my second picture, again, 3 missing angles. I'm going to see what their measures are and give a reason as to how I know that. And I'm going to start with angle 1 this time. I see this line intersects with this line right here, creating vertical angles. Angle 1 and 114 degree the 114 degree angle are non-adjacent vertical angles, which means they're congruent. So angle 1 has to be 114 degrees. 114 degrees because it is vertical to the 114 degree angle. All right, it is vertical to 114 degrees. All right, and I have a similar reasoning down here with angle number 2. This line and this line intersect right here, creating vertical congruent angles. Okay, they're across from each other from that point of intersection. They're non-adjacent and they are vertical and congruent. So the measure of angle 2 has to be 43 degrees because it is vertical to 43 degrees. Okay, and now I can get angle number 3 up here. I could have gotten that right after angle number 1. I actually didn't need an angle 1 to get it because angle 3 and my 114 degree angle here create this straight angle here, making them supplementary, meaning that their sum is 180 degrees. So to get the measure of angle number 3, I'm going to have to take 180 degrees and subtract off 114 degrees. And when I do that, that's going to give me 66 degrees. So this is a 66 degree angle. And I know that the measure of angle 3 is 66 degrees because it is supplementary. It is supplementary to 114 degrees.